Okay, pre-cal, in this video we are in Unit 8 and we're talking about Topic 3, so we're working with oblique triangles. And in this video we're going to talk about the law of sines. So these laws are used to solve oblique triangles, and when I talk about oblique triangles, that just means that they're not right triangles. That's all that means. So I've got a picture drawn here of a triangle, which clearly is not a right triangle. And if you'll notice, all of the vertices are labeled with capital letters, and all of the sides are labeled in lowercase letters. And also I want you to notice that side A is across from angle A, and side B is across from angle B, and side C is across from angle C. So that is always how we're going to draw these. So just make sure you read through your hints for solving. I am going to touch on these a little bit as we go through. Keep in mind that when you have a triangle in which you have two of the angle measures, you can use the triangle sum theorem to find the third angle, because remember, all angles have 180 degrees inside them. Okay, make sure that your calculator is set on degree mode, and keep in mind that when it says we're solving the triangle, that means we're finding all the missing angles and sides. So we're going to, as a rule, round our side measures to the nearest tenth and our angle measures to the nearest whole degree, unless you're told otherwise. So these are just our rules when you're not told how to round. Okay, so what is the law of sines? The law of sines, we're just going to use two fractions that have a relationship to set up a proportion. So we need to think of the law of sines as one of three different ways that we can do this, because we have triangles, three sides, three angles. You'll see what I'm talking about. So the law of sines tells me that side A is to sine of angle A, as side B is to the sine of angle B. So that's one way you can set up your equation, but notice that there's a side left out, not side C. So you can set it up that way depending on the pieces of the triangle you have, or you might want to set it up as side A over sine of angle A equals side C over sine of angle C. Or another option, you might have side B and sine of angle B and side C and sine of angle C. And it just depends on what pieces of the triangle you have. So we're going to jump into an example here. We can use the law of sines in three situations, basically. And this first example is ASA. That means we have an angle, side, angle. And then in the next example, we'll look at angle, angle, side. And then, of course, we'll look at the third case, which would be side, side angle, and it's a little tricky. So these are the three cases we will talk about in our examples. Okay, so let's jump right in here. Example 1, we have angle, side, angle. So given the triangle ABC with the following measures, find the missing measure. So I'm just going to draw a triangle here. And again, like I said, it does not have to be perfectly to scale, because it's not. So 49 degrees for angle A, 57 degrees for angle B, and side C, of course, is across from angle C. So that's 8 centimeters right there. Okay, so the very first thing I'm going to do is do the easy thing. I am going to find the measure of angle C. And it is just going to be 180 degrees minus 49 plus 57. Because if I add these two together and then subtract them from 180, I am left with the third angle measure. And this is going to give me 74 degrees. So I've already got one piece of my triangle solved. Excellent. Okay, so let me switch colors here. So I've got 74 degrees right there. So now I'm going to work to find side A and side B. So I am going to set up a proportion with my law of sines. So I'm going to set up side A is to sine of angle 49. And now I have to choose a side and angle relationship that I already have because my variable is already in my equation. I can't have two variables. So I am going to choose angle C and its side opposite it. So I'm going to have 8 times the sine of 74 degrees. And so now I'm just going to cross multiply here. So I've got A times the sine of 74 equals 8 times the sine of 49. And now I'm going to divide by the sine of 74. And then this is going to be an approximate value. And I'm not going to get the calculator out here to show you. But if you're using your calculator, it will automatically open parentheses here between sine and 49. Make sure you close the parentheses before you divide by the sine of 74. So what you end up getting here, you end up getting 6.3 centimeters because we're rounding to 1 decimal place. So that is what we end up getting for A. And now we're ready to move on to B. So we found angle C, we found side A, now we're looking at our final piece here. So I want to know what side B is. So I'm going to set side B over the sine of 50, oh man, B over the sine of 57 degrees. And then I am just going to use that relationship between 8 and the sine of 74 again. I don't want to use A and the sine of A because this is a rounded value and 8 is not rounded. It was given to us. So it's going to be a more accurate situation. So I'm going to, again, cross multiply. And I'm going to divide both sides by the sine of 74. You'll notice you need to do all of this before you do any calculations in your calculator. So again, I'm just going to type this into my calculator just like that with parentheses right here. And this is going to give me 6.99, I believe. So this is going to round, of course, to 7 centimeters. Awesome. Okay, so that's how you do the angle, side angle for the law of sines. So we're just going to move on to example 2 here. And we are going to, again, draw our triangle. So I've got triangle ABC. So A is 35, B is 103. So that is going to be obtuse. So I know that I want my 103 here. A is 35, we're looking for C. Side B would be across from B, so that would be 20 inches right there. So the first thing I'm going to do is the obvious easy thing. I'm going to find the measure of angle C. Oh, and I didn't talk about this on the last problem, but angle, side angle. See, I was given the angle, then a side in between, and then the angle. So that's where we get angle, side angle. And this one, of course, is angle, angle, side. So I've got angle, angle, side. So it goes right in order as you read around the triangle. Okay, so I'm going to start by finding the measure of angle C because that's the easiest part. So I'm going to have 180 minus the other angles added together. And then that is going to give me the measure of 42 degrees. Okay, so that's the first thing. We're going to switch colors here. And now I'm going to find A and C. So I'm going to set this up as A over the sine of 35 degrees and 20 over the sine of 103 because those are the values that I have right there. So A times the sine of 103, 20 times the sine of 35, divide both sides by sine of 103. And then I have A is approximately, and of course you're going to type this into your calculator. Sorry I'm not showing you that, but my videos are getting too long, I'm afraid. Okay, and then I've found A, I found my other angle at 42 degrees, so now I'm ready to find side C. So side C over sine of 42 degrees equals 20 over the sine of 103. So I'm going to cross multiply. Going to divide by sine of 103. And then, of course, I'm going to put this into my calculator. Again, don't forget your parentheses here. It will screw up the problem. And we get 13.7 inches. Now, the nice thing about your triangles is that you can always check to see if you're right, because remember your triangle rules, your longest side is across from your biggest angle, and your smallest angle is across from your smallest side. So notice 20 inches is our longest side across from the biggest angle, and 35 is our smallest angle, and A is less than side C. Beautiful!